All right, so get this.
Okay.
You take a single photo, like just a snapshot of your living room,
Uh-huh.
and you can generate a full 3D scene. Like you can actually walk around in it.
Yeah.
Even with like your cat realistically walking across the couch in 4D.
It's wild, right?
It's like stepping into the photo.
It really is.
That's DimensionX, the research we're going to unpack today.
Yeah, it's pretty amazing how it builds on all this video diffusion stuff.
Oh, yeah.
You know, those models that can already make these really lifelike videos.
Right.
But then to take that and go, okay,
Yeah.
how do we turn this into an actual 3D space?
Yeah, how do you make that jump?
Like from a flat video
Yeah.
to something you can explore.
Right.
That's the really cool part.
Yeah, what is that secret sauce?
Well, so think about it this way.
Okay.
When you watch any video,
Mm-hmm.
you're seeing things change over time, right?
The temporal side.
Exactly.
Yeah.
And you're seeing it from different angles.
The spatial stuff.
Exactly. That spatial part.
Yeah.
And DimensionX found this really clever way
Right.
to separate those two elements.
So it's like,
Like you're
yeah.
watching a movie
Mm-hmm.
and you can rewind and fast forward the action.
Right.
But you can also like grab the camera and fly it around the scene
Okay.
to see everything from...
It's like you have these separate controls,
Yeah.
one for the action and one for the viewpoint.
Exactly. And they do this with these special modules they call directors.
Okay.
It's like having two directors on a movie set,
Interesting.
each one focused on a different aspect.
I like that.
So you have the S director, who's all about the spatial side,
Okay.
like your camera operator.
Uh-huh.
And then the T director, who manages the temporal part,
Okay.
controlling how things move within the scene.
So it's like
Yeah.
one director is controlling the set
Yes.
and the other one is controlling the actors.
Precisely.
I like that.
It's a really elegant way to think about it.
So then how do they work together?
To make a whole 3D scene, well, by combining these directors, you get videos that have both camera movement and object movement.
Okay.
And that's the key.
Right.
Now you have the building blocks for a 3D scene.
So like those old flip books
Yeah?
where each picture is slightly different
Exactly.
and it creates that illusion of motion.
It's taking that concept to another dimension.
Literally. Literally.
But to build a 3D scene, you'd need a ton of those pictures.
Right? You're absolutely right.
Like way more than a typical video.
That's one of the big challenges they had to figure out.
Interesting.
They found that you need a lot of frames to make it truly immersive.
Okay.
Way more than what you'd usually get.
So did they just crank up the number of frames?
Well, yeah, they did increase it
Like,
to a whopping 145 frames.
wow.
3 times the original.
Okay.
But it's not just about quantity.
Right.
They also had to deal with how camera movement can vary so much,
Yeah.
you know, in real life.
A slow zoom in a nature documentary is totally different from...
Someone running around with a camera.
Exactly. And that's where it gets really clever.
So how do they teach it to handle that?
They trained multiple S directors.
Oh, wow.
Each one specialized for a specific type of movement.
So like one for a zoom,
Yeah.
one for a shaky cam,
Exactly.
one for like a panning shot.
They have 12 based on different degrees of freedom,
Wow.
like up and down,
Okay.
left and right.
Got it.
And then one special one just for orbital motion.
So like when you're circling an object?
Precisely.
That's so cool.
So no matter how the camera's moving,
yeah.
they've got an S director ready for it.
Like a whole team of expert camera operators.
Exactly.
Okay, but back to the single image thing.
Yeah.
Can it really work with just one photo?
That's what's so powerful about this approach.
Okay.
DimensionX can work with either a single image
Uh-huh.
or just a few sparse views.
So it's really flexible.
It can handle a lot of different situations.
That's amazing.
Now things get even more interesting when we talk about 4D.
Okay, 4D scene generation.
Making things move within that 3D scene.
That seems like a whole other level.
It is.
What were the big challenges there?
The biggest one is definitely consistency.
Okay.
As the scene changes over time,
Mm-hmm.
everything needs to stay looking realistic.
Right. You don't want like
Yeah, you don't want buildings morphing.
the background suddenly changing
Exactly.
or objects just glitching out.
It needs to be smooth and natural.
So how do they do that?
They developed some very clever strategies for what they call preserving identity.
Interesting.
It's all about ensuring that things look and behave the way they should,
Okay.
even when they're in motion.
I like it.
One strategy involves sharing the latent code from a good reference frame.
Okay, hold on.
Yeah.
Latent code.
So think of it this way.
Okay.
Latent code is like a hidden blueprint
A blueprint.
that captures the essence of the scene's appearance.
Okay.
And by sharing this blueprint from a good reference frame,
Uh-huh.
they essentially anchor the scene's look to that frame,
So like,
like a style guide
yeah.
that everything needs to follow.
Okay, cool.
So the background, the lighting,
Yeah.
it all stays
Even
consistent.
as things are moving around.
Exactly.
That's smart.
And they also add another process for appearance refinement
Okay.
to iron out any little inconsistencies that might still pop up.
So like a final polish?
Exactly.
Wow, this is getting really complex.
It is pretty amazing.
But I think we should probably pause here.
Okay?
And we'll pick up the rest of this DimensionX journey in part 2.
Sounds good. Welcome back.
Okay, so before the break,
Yeah.
we were talking about those 4D scenes
Right?
with moving objects.
Mm-hmm.
And you mentioned something called deformable 3D Gaussian splatting.
Yeah. It's a mouthful, isn't it?
What is that all about?
It's basically a really cool way to represent and render these dynamic 3D scenes.
Okay.
It uses these tiny little building blocks.
Like little Legos.
Kind of, yeah, they're called Gaussian splats.
Gaussian splat.
And they're used to create the shapes and appearances of everything.
So like the objects in the background,
Yes.
they sound kind of like like digital clay or something.
That's a good analogy.
You can mold them into anything.
Yeah, you can stretch them, squash them, move them around
And that's how they build the 4D scene.
from those multi-view videos we talked about.
It's like building a world out of millions of tiny Legos.
But these Legos can change shape.
That's wild.
It's pretty amazing.
So how does DimensionX actually compare to other methods out there?
Good question.
Did they do any like head-to-head comparisons?
They did.
Okay.
And the results were really impressive.
Tell me more.
They tested it on both real-world footage and computer-generated data sets,
Okay.
comparing it to existing methods for creating controllable videos and 3D and 4D scenes.
Can you give me some examples of the data sets?
Yeah.
Like what kind of scenes were they working with?
So for controllable video generation,
Uh-huh.
they used a benchmark called VBench,
Okay.
which evaluates things like how consistent the subject is,
Mm-hmm.
how dynamic the motion is,
Right.
and even the aesthetic score of the videos.
Wait, they're judging how pretty the videos are.
Well, it's not just about personal preference.
Okay.
It's more about how visually pleasing and realistic they are.
So like,
Does it look believable?
yeah, does it draw you in?
Exactly.
Cool.
And DimensionX consistently outperformed other models,
Oh, wow.
including open source options like CogVideoX
Uh-huh.
and even a commercial product.
So it's not just a tech demo.
It's making some seriously good-looking stuff.
I like it.
Yeah.
What about 3D scene generation?
For that,
Yeah.
they used established data sets like Tank and Temples,
Okay.
MIPNER of 360, NER-RLLFF, and DL3DV10K.
Those are like the standard benchmarks, right?
Exactly. They're
Yep.
designed to be challenging.
With lots of different indoor and outdoor scenes.
A real test for these 3D reconstruction techniques,
And I bet they use those standard metrics.
like PSNR-SM
Yeah.
and LPIPS,
Yeah.
to measure the quality.
Right.
And once again, DimensionX came out on top, delivering better results in both single view and sparse view scenarios.
So no matter how much visual information you start with,
Yep.
DimensionX can create a detailed and accurate 3D representation.
It's incredibly adaptable.
This is really impressive stuff
It is.
to make sure their findings were solid.
Yeah. Did they do any, like, ablation studies?
They did
Okay.
to see how each part of the framework contributed to the results
So, like, taking the machine apart.
and testing each piece
Yeah.
to see what it does.
That makes sense.
One study focused on the importance of their trajectory-aware mechanism for 3D scene generation.
So, like, those specialized S-directors.
Right, the ones for different camera movements.
Okay.
They found that removing those S-directors really hurt the quality.
Especially for wide-angle views.
Exactly.
So those are really important.
Crucial.
What other insights did they get?
Well, they also looked at the impact of their identity-preserving strategies for 4D.
Those strategies for keeping things consistent
Exactly.
as objects move around, like making sure the background doesn't suddenly change.
Yeah, or objects don't morph.
Right.
I bet those are essential for 4D.
Oh, absolutely.
What happened when they removed them?
The 4D scenes basically fell apart.
Oh, no.
Backgrounds shifted, object shapes distorted.
It sounds like a mess.
It wasn't pretty.
So they're not just stitching together random frames?
No, they're making sure everything works together seamlessly.
To create a realistic dynamic scene.
That's the key.
That's really impressive.
But like any new tech, there are still limitations.
Right. Nothing's perfect.
DimensionX is pushing the boundaries.
Yeah.
But there's always room for improvement.
Okay, so what are some of the limitations?
Well, one of the main ones is that the quality of the 3D and 4D scenes is still limited by the video diffusion model.
even though those models are really
It's
advanced.
still not perfect.
So they're hitting a
In
ceiling.
terms of capturing all the detail and nuance,
Okay.
and that's where a lot of research is focused right now.
On making those models even better.
It's a constant evolution.
Exciting times?
It is.
Yeah.
Any other limitations?
Another one is the computational power needed.
Oh, yeah, that makes sense.
It takes a lot of computing muscle to generate these high-quality videos and then reconstruct the scenes.
So this isn't something you could do on your laptop.
Not yet, at least.
But as computers get more powerful,
And the algorithms get more efficient,
yeah,
it'll become more accessible.
that'll be great.
I will.
But even with those limitations,
Yeah.
the potential here is undeniable.
It's huge.
Just imagine
Yeah.
creating photorealistic 3D and 4D experiences from a single image.
It opens up so many possibilities.
In VR entertainment scientific research.
Wow. The list goes on.
And that brings us to the big question.
So what question?
Yeah.
How could this actually change our lives?
What does it all mean for us?
That's what we'll unpack when we come back for part 3.
All right, so we're back and ready to really explore this DimensionX thing.
Yeah. Time to zoom out a bit.
Yeah, big picture time.
How could this tech actually change the world? All right, what are the most exciting applications?
Oh, man, so many possibilities.
Where do you see it making the biggest impact?
Entertainment media, for sure.
Okay, yeah, I can see that.
Like, imagine creating these immersive virtual worlds that feel totally real.
It's like those holodeck things from Star Trek,
Exactly.
but actually real.
Not just some clunky VR experience.
Yeah, this is like stepping into another reality.
And it's not just static environments either.
Right, because we're talking 4D here.
You could have moving objects, interactive elements, storylines that adapt to you.
It's like next level gaming in VR.
Way beyond anything we have now.
I could explore ancient ruins from my couch.
Or alien planets.
Yeah, and it'll feel like I'm really there.
And think about filmmaking.
Oh, yeah?
You could generate entire sets from concept art.
Wow.
Film scenes with virtual actors.
That's wild.
Give viewers control over the camera.
It's like giving filmmakers godlike powers.
Pretty much.
But beyond entertainment.
Yeah.
This could be huge for things like architecture and design.
Absolutely.
Architects could create virtual walkthroughs,
Before the building even exists.
so clients can experience the space.
And give feedback.
It's like those 2D blueprints come to life.
You can walk around and really see it.
And interior design, too.
Oh, yeah.
Try out different furniture layouts.
See how the space feels?
Oh, I love it.
What about education and training?
Oh, okay. Yeah, the possibilities are endless.
Students exploring ancient Rome in VR.
Oh, wow.
Dissecting a virtual frog.
No actual frogs harmed.
Exactly.
And training for dangerous jobs in a safe simulation.
It's all about making learning more immersive
More engaging.
and more accessible.
And we can't forget about science.
Oh, yeah.
How could this impact research?
Researchers could visualize complex data sets,
Okay.
create 3D models of molecules,
So cool.
or even simulate entire ecosystems.
To study things like climate change.
That's a whole new way to understand the world.
This has been an incredible journey.
It really has.
DimensionX is mind-blowing.
And this is just the beginning.
Who knows what other breakthroughs are coming?
We're living in exciting times.
For those listening,
Yeah.
check out the DimensionX project page.
Visual examples are amazing.
You have to see it to believe it,
And maybe you'll be the one.
to unlock the next big application.
Keep those imaginations running wild.
The future is full of possibilities.
DimensionX is just a glimpse of what's to come.
Until next time, keep diving deep.